Okay, so this is problem 24 of the sprint round, which reads triangle ABC has side lengths AB equals 13, BC equals 14, CA equals 15, and the altitude from A to BC intersects the inscribed circle of triangle ABC at points D and E, and we're asked to compute D. And so what I'm going to do is I'm going to make a diagram and um, we'll have the inscribed circle and three sides. And this triangle 13, 14, 15 is actually probably one of my favorite triangles, and that's because of how nice all the numbers work out when you get to it. So let's see, get this diagram right, and then what we have is the inscribed circle and ABC, where AB is 13, BC is 14, and CA is 15. And the reason this triangle is so nice, and you may or may not have seen this triangle before. If so, you may already know this trick. If not, what I do is I drop an altitude from A to BC, route right here. And so I drop this altitude, and all of the numbers work out almost perfectly because this side is 13, this side is 15, and because this side is 14, we could actually solve for the height of this triangle because we're going to say this length is x up to this point over here, which we're going to denote as point P. This is 14 minus x, and then we're going to say this length of this height is h, and Pythagorean theorem would give us the two equations, x squared plus h squared equals 13 squared, which is 169, and 14 minus x squared plus h squared is equal to 15 squared, which is 225. And now what I can do is I can subtract the first equation from the second equation. And what I end up with is 14 minus x squared plus h squared minus x squared plus h squared is equal to 225 minus 169, which is equal to 56. And you can cancel out this plus h and this minus h, and you're left with 14 minus x squared minus x squared. And you can expand both of these out. You get like x squared minus 28x plus 196 minus x squared is equal to 56. Of course, you cancel these two out and you rearranged. So you get 28x is equal to 196. This should be a 196 minus 56. So x is equal to 5, meaning 14 minus x is equal to 9. So I can get rid of, wow, this is a very sensitive eraser. This is 5 and this is 9. And if you solve for h, 13 squared minus 5 squared, 169 minus 25, you get 144. So h is equal to 12. And, whoa. And what this means is that because all of these lengths are so nice, we can actually put this on a coordinate plane. 12. We can put this on a coordinate plane where this point P is 0, 0. Point B is -5, 0. Point C is 9, 0. And point A is 0, 12. And we can make our axes right about like this and like this. And what do we want? We want to compute D, where D is about here and E is about here. And what's awfully convenient is that both D and E are on the y-axis, which means that if we were to be able to find the equation of this incircle, we could just say, you could just plug x equals 0 into the equation and solve for y, and that would give you your two coordinates of D and E. And the real question becomes like, how do I find the equation of the circle? Because that's not immediately obvious, but let's say we have our center of the circle about here. The nice thing about this in-center is that you can drop perpendiculars here, here, and here. And all three of these perpendiculars, they're equal to the same length, which we call the in radius. Whoa. We call that the in radius, which we can denote by r. And what's nice about the in radius is there's actually a formula to calculate it. You have this in radius, which is equal to the area divided by half the perimeter. Now, the area of this triangle is equal to 1/2 times the base 14 times the height 12, which is 84. So this area is 84. The half of the perimeter is 13 plus 14 plus 15 divided by 2. And if you add this up, you get 13 plus 14 plus 15 is 42, divided by 2 is 21. So your in radius, r, is equal to this area, which we can calculate to be 84, divided by the in radius, which is 21. The semi-perimeter, which is 21. Get that, the in radius is equal to 4. So r equals 4. And how does that help us? Well, it helps us because what we can do is we could pretty easily find the y-coordinate of the center, which is 4, because the in radius is 4, and this radius, which is perpendicular to the x-axis, must end in the point with coordinate 4. Now, in order to find the x-coordinate, there is a formula where if you have any triangle and the incircle, so if I have any triangle and I have its incircle, you could find like what this incircle splits the sides into by using a formula where if this side is length A, this side is length B, and this side has length C. This length over here is A plus C minus B divided by 2. And you can repeat that for any segment like this one. But my point is, this distance over here is 15 plus 14 minus 13 divided by 2, which is equal to 8. So this distance is 8, which means that the x-coordinate of this point in the center is 1. So the center is at 1, 4, and the radius is 4, which means that we can indeed write down the area, the equation of the circle as x minus 1 squared plus y minus 4 squared is equal to 4 squared, which is 16. Now, what do I want? I want points D and E, which occur when x is equal to 0. So you plug in 0. And what you get is 1 squared plus y minus 4 squared equals 4 squared. So y minus 4 squared is equal to 15. Y minus 4 equals plus minus root 15. And y is equal to 4 plus or minus square root of 15. And thus, the coordinates of points D and E are 0, 4 plus minus square root of 15. So the distance between D and E is the difference in their y coordinates, which is 4 plus square root of 15 minus 4 minus square root of 15, which is equal to 2 times the square root of 15. Now, if you look at all these answer choices, you see that 2 times the square root of 15 is none of the answer choices, so your answer is E, other. And we are done.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.